today is our fourth video. We'll see the relationship between the voltage and the energy, and the relationship between the energy and the power. We have the voltage. The voltage is the difference of potential between 2 points. In that, if for example we have the voltage, let's say for example we have AB, you have this point A and point B, so the voltage across the source, it will be VAB, which equal the potential of at point A minus the potential at point B. Mean that if I write VAB, mean that the potential equal the potential at point A minus the potential at point B. But if I write VBA, it is equal the potential, since it is the point B we start from the notation, it will be potential of point B minus potential of point A. If I start VAB, is going to be the potential at point A minus the potential at point B. But if I start VBA, is going to be the potential of at point B minus the potential at point E, which equal mean that these 2 points to VEB equal minus VBA, mean that you have to be opposite with negative sign. That's the voltage. The voltage, let's say for example we have a source, of 9 volt. Mean that 9 volt, if I write 9 volt, mean that it will be the potential at point of the positive terminal minus the potential of negative terminal. That will give me 9 volt, which is the V equal 9 volt. Volt is the unity of voltage. So mean that this source, the maximum voltage that can carry or can have, it's 9 volt. That's the voltage of this source. Such as battery, we have a battery, like there is battery of 12 volt, there is battery of 12 volt, there is battery of 9 volt. Mean that this one are the voltage of the battery. So this voltage, it has a relationship between the voltage and the energy. Volt V, it is equal the derivative of the energy by with respect of Q. That's the, we'll see the variation or the relation between the voltage and the energy. That's the voltage of this one. Every element can have the voltage of across that element. Let's say for example we have the resistor R1, we can say VR, means that the voltage across this resistor. So next we'll see the relation between the voltage and the energy. V, we say V equal derivative of the energy with respect of Q, with respect of charge that's across the element. So the voltage is the derivative of the energy with respect of charge. We have to keep it in mind as a formula. In this case, I can also determine, let's say for example, if the energy does not depend on charge, I can say V equal the energy divided by Q. Mean that energy is constant, Q is also constant. It's the same formula. We have to also keep in mind that If I have the voltage, I have the charge, I can determine the energy. Same, if I have the energy, I have the voltage, I can determine the charge. So now let's see what is power. Power. Power is the rate of energy. And if we say rate energy, means that the energy consumed per second, which equal P, which is equal the energy with respect of time. We have to also know it. Mean that power is the energy with respect of time. Mean that energy divided by time. It can also write in P equal derivative of omega with respect of time. D omega means that the derivative of the energy with respect of time. This formula is same this one. The only difference this one, this energy now it is constant, the time is also constant. So just a derivative mean that I just to take the value of the energy that is constant divided by the time that's the element already passed. Now by this one, if the energy was given, it is a function of time. To determine the power, I just derivative with respect of time. That's the only difference. Now I want to see the relationship between the power, voltage, and the currents. I already know that power equals derivative with respect of time of energy, derivative of energy with respect of time, which I can write equal derivative with respect of charge multiply. I want to get the same as this one. So to get at the same as this one, I can take this numerator, like derivative of the charge with respect of time. Because if I simplify this one with this one, it will only remain derivative of energy by t with respect to time, which equal this one. If we remember the previous one, we say this one is the voltage. This one is the voltage. The voltage we already write that. The voltage is the derivative of energy with respect of charge. The previous lesson, we see that derivative of charge with respect of time equal current. So from here, I can determine that power equal voltage multiplied by currents. I have to keep it in mind. Like if I have the voltage of the element, I have the currents, I can directly determine the power because I just multiply the voltage and the currents. Now we'll see some example to see how. Another example, he can give you only the charge. We saw the previous one. If he give me the charge, from the charge I can determine the currents. So if I have the current, I can directly determine the power by multiply by the voltage. Let's see an example. In this example, he told us the current throughout and the voltage across an element. We have element. The element, we don't know it. Sketch the power delivered to the element for t greater than 0. We want to find what's the power. So I have to see the given that you already give. He give me what? He give me the current and he give me the voltage. I already know the formula that I will apply. That P equal V multiplied by I. So, but if we will see from 0 to 2, it's not the same curve from 2 to 4. So I have to determine the power from 0 to 2, mean that from 0 t to 2, I'm going to determine the power. I know the formula, power equal V multiplied by I. What is the V? The give from 0 to 2, the V already given. My V equal 5. 5 watts. 5 volt, of course, because I know the unity of voltage is 5. Now, what is the current from 0 to 2? From here, from the previous lesson, we see how to determine the function in a straight line. Mean that Et is going to be equal mt plus b. Now, since it is passed in the origin, the b is going to be equal 0. This b equals 0. It's going to be equal empty directly. Now, how to determine the value of m? To determine the value of m, I will have m is going to be 60 minus this 60. If we take this one, it's going to be 60, the last point, minus the first point. What's the first point? Is 0. Divide by, from 60, what was the t, the time? The time was 2. I have to take 2 minus what's the time here? It will be 0. So equal 30. Now, my m equals 30. So I have ET. My current is going to be 30 T. I don't need to calculate the B, because since it's passed in the origin, the B equals 0. If my curve does not pass in the origin, I have to calculate the B. How? By using the previous formula and the previous method that we used in the previous video. Now I have the voltage. The voltage is V equal 5. I have also the current. I can directly determine my power. My power equal V, which is 5, multiplied by current. What is my current? 30 T. So my power is going to be 5 multiplied by 30, 150 T. 150 T. Means that is my power. Now we have to see. Now I have to determine from 2 to 4. From 2 to 4. When 2 less than T, my time is between T to 4. So it's going to be equal. The same formula. What is my V? From 2 to 4, my V is here. Equal minus 5. V equal minus 5. Now, what is my current? My current, I have to determine ET equal MT plus B, the general formula. Now, what's the value of M? To determine the value of M equal, I take. Now, the value of M, I can start from the first point. The first point is 60 minus. What's the second point? The second point is 60, it was here, the first point. I take the I, 60. Minus this in the second point, what's the value? The value is 0, minus 0. Divide by, just to come the first point, it was what? It was 2. It's going to be 2 minus the second point at which time? 4. Minus 4 equal minus 30. Now, I already determined the value of M. I have to determine the value of B. Mean that my IT is going to be equal minus 30T plus B. Let me determine. Now let's go to determine the value of B. I have to choose one point. I can choose this point. I can choose also this point. If I choose this point, in this point, what's the value of Q, the I? The value of I is 60. If I choose this point, the value of I is 60. The value of T is 2. 7. If I choose this point, the value of I is 0. The value of B, T, it is 4. So I take this point because I have, it will be easier for me. The value of I from this point, it is 0. 0 equal minus 30 multiplied by T. What's the value of T? Value of T, it is 4 plus B. Now B is going to be equal what? Minus this one is going to be minus 20, minus 120 plus B equals 0. Means that if I take minus 20 to come here, B is going to be 120. B is going to be 120. Now I already found the value of my IT is going to be minus 30T plus 120. Now I have the value of I have the value of V. I can determine the value of P. How? By using the same formula. P equal V multiplied by I. So my power is going to be V, which equal minus 5 multiplied by I minus 30T plus 120. 120, which is it will give me this one is going to be 1500 t minus if I multiply with this one is going to be minus 50 minus 6000 means that's the value of p. Now I already found the value of p. I have found the value of p from 0 to 2. I found the value of p from 2 to 4. Now I will go and sketch it. I will go and sketch it. How to sketch it? Now to determine, now we already found the value of p. We'll determine the value of t. Next video we'll see the sketch of that power and to answer the second question, which is the energy of that example.